Okay guys, so today we're going to be working on objective 2.2a actually. So we've left 2.1 factoring polynomials to now we're going to be solving by factoring, and we're solving quadratic equations. So our objective is I will be able to use my factoring skills and the zero factor theorem to solve quadratic equations. Now you may say, well, but I can solve a quadratic equation using the quadratic formula. And you're right, you can. And the quadratic formula always works, but it only works on quadratics. It doesn't work on a cubic function or on a higher degree function or higher degree equation, excuse me. I meant equation the whole time. So, but factoring tends to be really helpful when you're solving a cubic equation, etc. And plus, a lot of times when something factors, it factors quickly and you can solve the equation quickly. So we're going to work on factoring to solve equations. Let's define what's a quadratic equation. A quadratic equation is a degree of 2 equation. In one variable written in the form ax squared plus bx plus c equals 0. And we call this a quadratic equation. Well, we call that the standard form of a quadratic equation. Okay. All right. So let's talk about what a degree of 2 means real quick. How do I know a quadratic is a degree of 2? What's Aries?
The AX is the power of 2 and not anything below or above that.
Right. The highest, you're right. The power of 2 is the highest power in the equation, so that makes it a degree of 2. How many solutions, what is the max amount of solutions that you can get from a quadratic equation? Raise your hand. Or show me with your fingers. What's the max? How many solutions can you get from a degree of 2 equation? The degree of 2 is the hint. You can get 2. That's the maximum. You could also get 1. And quadratics always have solutions. They're either real or they're imaginary, but they all have solutions. It's not like a linear where you can get a no solution. There are solutions. Okay? So let's just note right here, max solutions for today, max solutions 2. Okay? And we're factoring, so we're not going to be finding any imaginary solutions today. So we'll go deeper into that when we start talking about completing the square and using the quadratic formula. Okay, so max solutions 2. Sometimes only 1. Minimum would be 1. That could be, we could put that. Min solutions 1. Either has 1 or it has 2. So keep that in mind. Now, what is the zero factor theorem? So what's a factor? Remind me. What's a factor? Come on. Really, guys? When we're talking about math, what's a factor? Two numbers that you multiply. The numbers that you multiply to get a product are called factors. So this is the zero factor theorem that says this. When two or more numbers have a product of 0, at least I didn't make that A right. One number is 0. Why is that important? Because we use the zero factor theorem to solve quadratic equations when we use a quadratic formula or when we factor. It's just the simplest way to find factors is to make them equal 0. Let's see. For example, if I said this, pi times something equals 0, what does something have to be? At least one of those factors has to be 0, and it doesn't matter what number I choose. If I get a product of 0, at least one of my factors has to be 0. Okay, the last term that you don't see there on my screen but is on your notes is substitution. And we're going to be using substitution today in the last two problems. So substitution is just replacing one thing with another thing. That's substitution. Like, for example, in your life, say you're wanting to cut calories because you're trying to make weight for wrestling or whatever. And so you're drinking coffee every morning to keep you going, but you got to have sugar in it. But you don't need sugar because you've got to cut weight. So you substitute it with stevia or sweet and low or something. You use substitution. You exchange something for something else, right? Everybody gets that? Yeah. Okay, let's move on. All right, so let's look at the first question. That's probably too big. Let me break it down. There we go. Okay, so over here, off to the side, yes. Yes. We're going to put down the steps for solving a quadratic by factoring. So over here on the left-hand side, you could write that down, the steps for solving a quadratic by factoring. There are 4 of them, so make sure you write small. These are the steps for solving a quadratic by factoring, not the quadratic formula, not completing the square, not square root property, factoring, which tends to be the fastest way to solve a quadratic. Step 1 is to write the equation in ax squared plus bx plus c equals 0 form. Put it in standard form. Make it equal 0. Because what we want at some point is one factor times the other equals 0. Step 2, as always when we factor out the GCF, greatest common factor. Make it easier on yourself. And then step 3 is to factor until all variables are degree of 1. Get all those exponents down to 1. In step 4, you're going to use the zero factor theorem to solve. The equation. Now, as I've said to you, this should be a review. This should be something you've done before. Hopefully this isn't your first shot at it. At least we know it's not your first shot at factoring, right? Okay, so I'm going to erase that and clear it out. And we're going to start off with really basic problems. No big. I keep using 2 fingers. I got to stop doing that. Slide. Come on. I'm rearranging the page. Let me Control B. Why does he do that? Control Z. Go back, go back, go back. I don't want to do that. Okay. Oh. What's wrong with it is see what I've done to it? Give me a moment. I'm just going to go back until it does what I want it to do. Go back. I can't use my mouse. It's starting to annoy me. Okay. Yeah, I know. Whatever. Get over it. Get over it, people. Okay. There we go. Don't move it again. Dang it. I know what I'm going to do. Give me a moment. I'm going to pause the video. Where's the pause button? All right, sorry about that. Well, let's work on this one. Okay, so let's look at the first problem. Step 1 is to put it in standard form. Is it already in standard form? Yep, m squared, m to the first, no m. So next is to factor out GCF if possible. I see one. It is 3m times m minus 1 equals 0. So we use a distributive property to factor out the GCF. Now, are all my variables to a degree of 1? So I can skip step 3. Now what I'm going to do is set all of my quantities equal to 0. Look, it's either this has to equal 0, the monomial factor, or this binomial factor has to equal 0. One of them has to equal 0 if I'm multiplying them and I get 0. So let's get our answers. It's either 3m is equal to 0, or the other factor, m minus 1, is equal to 0. So, of course, we divide by 3 to isolate our m equals 0. Or we add 1, m equals 1. I would like for you to write your answers in solution set. So 0 or 1. Excuse me. Also, of course, you can check by plugging your answers in. So I'm going to quickly do that. You don't have to write it down on your notes, but know that you have the option. So if I plug in m is 0, 3 times 0 squared minus 3 times 0, will I get 0? Yeah, 0 minus 0, 0. Or if I plug in a 1, 3 times 1 squared minus 3 times 1 equals 0. Well, 3 times 1 squared is 3 times 1. Minus 3 times 1 equals 0. Well, that's true too. So we found both of the solutions. Okay. If you don't have questions, you do the next one. Be careful. Oh, make this an X, please. It's not an M. Oops. Yeah, it makes it a little harder in 2 variables. Okay, you should have got the answers 0 and -2. We're going to move on to the next problem. Here we go. All right, so here we have 3 different terms, an a squared, a constant, and on the other side, a -2a. Now, I wouldn't enjoy solving this equation in this form because it's hard to imagine what the answer is. But if I make it equal to 0, I make the situation a lot simpler for myself. So I'm going to take this 2a, I'm going to add it to the center in between my a squared and my 1 and make it equal 0 because I can now more easily see what my solutions are going to be. Okay, now we got a factor. No GCF, but paying attention. This is a perfect square, yes? This is a perfect square too. Is it a perfect square trinomial? The square root of those is a and 1. 1a plus 1a is 2a, so it is. So we could easily just factor it out into their square roots of a and 1, quantities squared, because we recognize the characteristics of a perfect square trinomial. All right, so how many solutions am I going to get? Some of you are saying 1, right? Because I'm going to write it twice, but isn't that a waste of my time, right? So I think that the note that you could make to yourselves today in regards to this problem is that anytime you're solving a perfect square trinomial quadratic, you're only going to get 1 solution. So a equals -1, I believe, is the answer to that. It's really silly to try to solve it 2 times. It's a waste of your time. So again, my note is when it's a perfect square trinomial, it's only going to have 1 solution. 1 solution. That's the one circumstance where you're only going to get 1. The rest of the time, you're going to get 2 solutions, 2 real ones, 2 imaginary ones. It's only perfect square trinomials that'll give you 1 solution. Okay? All right, so you go to this other one and don't get stuck. This one's not a perfect square trinomial. You actually have to factor it. Okay, so let's move on to the next group. Of course, it's working its way up in complexity, not really working its way up in difficulty, just complexity. Okay, so let's take a look at this next one. It is not in standard form. This is such a messy equation, and I wouldn't want to solve it in this form. I want to make it equal 0 so it's easier to tackle. So I'm going to add 2b squared to 3b squared. And I'm going to subtract 2 from -33. Combining like terms, you get 5b squared plus 30b minus 35 equals 0. Now, I could factor it in this form, but I see something that could simplify my process. What's our GCF? So let's factor it out so that our lead term is 1. So 5 times b squared plus 5 times 6b times 5 times -7. Okay, which makes it easy to factor, right? Because our a is 1. So we could just open up our binomial pairs and take our b and split it, b and b, take our b squared, and split it. And then let's go look at our factors for 7. The only way to get 7 is 7 times 1. So it's also negative, which means one of those two must be negative. So let's look at the middle term. It's positive 6. So which one should be positive? 7. And the b should be negative. So it's pretty easy to factor that one out. Now we're going to set, should we set the 5 equal to 0? Doesn't have a b in it, right? This is not 0. It's either this one 0 or this one 0. It's 5 times 0 times something, or 5 times something times 0. It's got to be one of those two choices. So these are the two that we're going to set equal to 0. The variables. Subtract 7, you get b equals negative 7. I'm out of space. Or add 1, and you get b equals 1. Okay? So again, not really complex. I mean, difficult, just more complex. Definitely more complex, but not very difficult. You guys go ahead and try the next one. Again, the answers were 2 and 7. Okay, so let's take a look at the last two problems. Now, what I want you to do over in the left-hand side is say, look at the structure. Use your eyes. Look at the structure of this problem. It's really not any different than the other ones that we've been looking at structure-wise. It's built the same way. It's just adding a little complexity is all. So let's take a look at this first problem. Is it in ax squared plus bx plus c equals 0 form? Are you sure it's not? Is this a number squared? Is this the number unsquared? Yes? And do you see a c? Well, that time there's no constant, but there was no constant in our first problem either. So what I'm going to tell you now is I'm going to sprinkle my powers on you. Here are my powers. You now have the power to take this complexity and make it simple by using what we call substitution. So I'm going to say we can see that this is basically structured in ax squared plus bx equals 0. It doesn't have the c, but that doesn't matter. Okay, so I pretty much actually could factor out what was there. It could, but I would rather not do that. So what I'm going to say is this. We're going to change this problem up and use substitution. Make it simpler. So let's say that we're going to let you pick a variable, not x. Somebody pick one. Okay, let y equal, we're going to let y equal 2x plus 3. I'm going to use substitution. I don't like the binomial 2x plus 3, so I'm going to use substitution. I have the power to do that. So I'm going to rewrite it like this. Y squared minus 2 times y equals 0. Because I got to tell you, I'd much rather factor that. I'd much rather look at that. I'd much rather deal with that. Okay, so I'm using y to replace their common factor. Yes? Okay, so now is it easy to factor? Sure it is. We can factor out a y, leaving us with y minus 2, right? And then we can go ahead and set those quantities equal to 0. Excuse me? It is a y. Would only not have to use it if it was an actual number. It's either this has to be 0 or this one has to be 0. One of them has to be 0. So I've got the solution that y is equal to 0 and it's equal to 2. I have two solutions, but that's not what I was asked to solve. I'm asked to solve for x. So I started out the problem substituting the 2x plus 3 with y. Now I have to undo that substitution and replace the y with the 2x plus 3. So I'm going to go back over here. I'm going to take my two answers. I'm going to replace y with 0 and I'm going to replace y with 2. But I'm going to say that they're equal to the original binomial factor that we replaced it with. And we're going to solve for x now. So we would subtract 3. 2x equals negative 3. Divide the 2. We're going to get x equals negative 3/2. Because that's what we're supposed to find, x. We could do it again. Subtract 3. We get 2x equals negative 1. Divide by 2. And we get x equals negative 1/2. So, just going to structure that up a little bit by separating that. So after we find out what y equals, we have to substitute it back in for y to find out what x equals. We call this substitution. Our final solution, of course, is negative 3/2. I'm out of space, so don't structure your paper like I did mine. But that's what x equals. It takes practice, so don't become overwhelmed or frustrated if it takes a little while to understand. You can always just work it out the old-fashioned way and do all of the math and take all of this, multiply it out, and then put it in ax plus b ax squared plus bx plus c. You can. It's just not the most efficient use of your time. Okay, I'm going to clear, and we're going to do one more together. Okay, and then we're going to be done. All right, so let's do this one. Now, is this one similar to the last one that we did? Okay, what are you seeing that these two have in common? Where do you see the 3x minus 1 over here? Factor out a negative 4, and that'll leave you with 3x minus 1. Oh, I'm so happy you saw that. Okay, so we would rewrite it to find the 3x minus 1. Our factoring skills are helping us out. Okay, this time we're going to let y equal, what are we going to replace? The 3x minus 1. So we're going to replace the 3x minus 1 with y. So y and y, I'm just replacing them in different colors there. Y squared equals negative 4y. So much easier to look at. Of course, it's not in standard form, so we need to rearrange it, right? So we'll add 4y. So y squared equals, or y squared plus 4y equals 0. Then we'll factor out a y plus 4. Set both quantities equal to 0. I'm out of space. Y equals negative 4. So I got the solution 0, negative 4. And remember, I'm not looking for what y equals, right? I'm looking for what does x equal. I'm moving back up. I'm moving back up. Let me see if I can scooch it up for you. Oh, that didn't work. Go back. Oh, that's okay. I just scooch it. There we go. Okay, I can't scooch it up. All right, now we're going to plug it in. So we're going to say, what is I? Y. Y is 0, right? And we're going to do 0 equals 3x minus 1. We're also going to do negative 4 equals 3x minus 1. So we can solve for x. So we'll add 1. 3x equals 1. Divide by 3. X equals 1/3. Or we'll add 1. Negative 3 equals 3x. So x equals negative 1. And we'll get our final solution. What I'm going to stick up at the top so everybody can see it. You can stick it wherever you want. We get the solutions negative 1 and 1/3. Okay. And so sometimes they seem more complex than they are. Again, I'm saying to you that it will take practice. It will, and that's okay. We'll practice some tomorrow.